That's magnitude 27 points in a direction 32 degrees above the positive x-axis.
All right, so right away, what's the x-axis? That's what you're going to do visually. Before you can go on. Above
25?
number...
Yeah, 25.
Okay.
126.
So think about the positive x-axis first, right? Here's the y-axis, here's the x-axis. That's how I visualize it. And if it's above the x-axis, that means the angle's measured like this. So just what they're stating is what they're talking about here. So this is the positive x-axis, this is the negative x-axis. So instead of saying northeast, we're saying a certain angle above the positive x-axis. It's the same thing as saying northeast.
Just the part where I would like to where to start, the second one?
Where you end the first one always. Always. When it's a summing of vectors, that was the first thing we learned in 4142. That's why I was like, this is almost the more important day, even though it was easier. Right? We did it graphically, where we had like the boxes, we counted the length of the vector on the bottom, we counted its width, we counted the height of the vector, then we went to the next one, counted the width, counted the height, and then we added those together. That's kind of what we're doing here. So what's the length and the angle of the next one?
Magnitude 35 meters and points in direction 35 degrees below the positive x-axis.
Okay, so ready? Here's what we do now. So this is where we left off. This is where it gets a little tricky. Remember what did I say? Call this the new origin. So now imagine an x-axis extending from this point. Because every time you get to an endpoint, it's like you're starting over for the next one. And the next angle they give you is with regards to the negative x or positive x-axis. Well, you can't use the same axis from down here, right? It's not reasonable. And that's probably part of the reason it's difficult to understand where to draw from. Because if you do draw from the end of the last arrow, you need to create a new x-axis. So you're not drawing from the original origin again and then trying to sum those together.
And you do that with the
Exactly. So you start from there and you draw a parallel line. That line is parallel to the actual x-axis itself that you started with. But that's like your new x-axis. And what does it say? 55 below?
Yeah.
So 55 degrees below would be an angle like that. So give me the actual numbers from the first part. So we have 55 here, and it was 35 magnitude, I think. And then what was the other angle?
27 magnitude and 32 degrees above.
Okay. So I don't know. This is a great question, because yesterday this question was posed by a couple students, or 2 days ago, just to say. How do I know if I'm still above the original x-axis? Did I not drop below? Maybe I'm above, maybe I'm below. You know what I mean? But by drawing it, I can't really see that, because unless I'm drawing things to scale, which I'm clearly not, looks like to me like the 27 vector I drew longer than the 35, right? When the 35 vector is clearly longer than 27, but it's not really shown that way in the diagram. So I don't really know where I ended up. Maybe I ended up with a resultant down here in the fourth quadrant. Maybe I'm still in the first quadrant. But if I use that table of values and I go through the components like we did in class, I'll see at the end if x and y are positive or negative overall. So remember, what am I really trying to do visually? I need to get the length of this vector along the x-axis, which I call the horizontal component. I need the horizontal component of this vector, which is that right there. And I need to add those two values together to see how far over I've moved to my ending result. And then I have to do the same thing with the y components. I need to find the height of this vector, or the y component. I need to find the y component of this vector right here. This one is going up, so that's positive. This one's going down, so I'm going to add a negative. And maybe that negative will cancel out all of that positive. I'll end up back at 0. It's possible. And I'd end up right there. That's where the actual resultant would be. But I don't know yet. So I have to look at the math to help me to understand that. So when I say draw a sketch of this, and I'm going to tell you something like this on the test, where you have to draw a sketch and then come up with the resultant, the table is really the more important part. So let's jump into the table. So for the table, I want you to start with x and y as your row headings, and then just put the vectors above. So in this case, since there's two of them, you can call them vector A and B. It doesn't really matter what you call them, really. Okay, and then finally over here we have the resultant vector. So what we do is we recognize that we can find those little components, those little pieces of each. So let's find the piece of vector A and the piece of vector B that's horizontal. And let's sum those values together and come up with an overall resultant. So how do I do that? There was a set of notes in 4142 in the beginning that we talked about finding the horizontal and vertical components, and I said to you specifically, I was like, you know what, this is one of those things that you're going to want to memorize, and it's on your formula sheet anyway, but you want to know these component parts. Okay, so that's going to go right here. So this is going to be a times whatever the sine of theta is. And then the other one? It's horizontal. So I have numbers for these, though. What does a represent? A represents the vector length. The vector length is 27. The angle theta is 32. So let's actually plug in those numbers now. So we've got 27 for A. And for theta, we're going to plug in 32. So I'm just erasing what was there and replacing it with vector length A for both of these. And then the angle theta, 32, for both of these. Why are they both positive? Why are both x and y components for the first vector positive? Think about the direction that the first vector takes you. It takes you which way? Two directions. It's this way in general, right? But in two directions it takes you to the
Northeast.
Yeah, northeast. So up, which is positive, and east, meaning to the right, which is also positive. So these are both positive values because of the directional on the vector itself. That's why they're positives. Now for B, you're going to have the same concept, right? But we're noticing for B, for the x component, we're going to the right still, so that's still positive. But then we're going down, which is negative in the y direction. So I can already put a negative right here. I can already put a negative there because I know that it's going to be going down in the y direction. But in the x direction, I'm still progressing over to the right, so that's going to remain positive. And then I take, again, the vector length times cosine of the angle. The vector length this time is 35. And we're doing cosine of the angle, which is 55. This is going to be 35 times the sine of the angle, which again is 55. Those are going to have numbers or numerical values, I should say. Sum them together, you'll get the x component of the overall result. Sum them together, you'll get the y component of the overall result. And then once we have the x and y, we can put it back together into like one triangle. So we need to go ahead and add these values, right? So these two are going to sum together right here and become what goes in this box. These two right here have to sum together and they become what's in this box right here. Do you understand why we're doing it? Can I draw the resultant on the diagram to help a little bit? Let me draw it in red. So it looks like the resultant vector of this overall thing would be all the way out here. And then for this case, the way we drew it a little bit up. But you know what? Remember we said we're not sure where this vector is really going to end. So maybe this triangle actually goes a little bit down. But remember the horizontal piece in red is really what's here in your x component of the resultant. So this is really our x, which is going right here. And we're going to put a number there. And then we're going to get our y in a minute. That's going to go right here. That's going to go right down there. And this is just the resultant vector, horizontal component. The resultant vector, vertical component. So sum these across. We need these numbers to know more. I can't go any further. And we really can't even investigate what this actually means until we have those numbers. Make sure you want to check on a calculator? Somebody's got it, yeah.
So you just add the 27 plus 13, 35 plus 55.
Yeah, so this is a product. So you can do it all in one line in your calculator. Just do 27 cos 32. We'll do that plus 35 cos 55, enter. And it knows to do one of the operations with multiplication first, and then to sum those two quantities.
So is that 23.3?
23.3? Okay, and then we need Ry. But remembering that Ry, we have a positive y component, which is this part going up. And then this vector is coming back down. That's why this is a minus instead of a plus.
So it would be plus or minus instead of just minus.
Where? Here?
Yeah.
It depends on which of these numbers is actually bigger, right? So like 35 is bigger than 27, so you think the answer is going to be negative. It probably is. But sometimes the angle can change it, because this is always a fraction between 0 and 1. So we don't know how much of a significance this is going to have. I mean, I know because I've done enough of this that this y component will be greater because the angle is more than 45. But for now, this could end up being like negative 20, and this could end up being 25, and then the answer would be positive still. So we have to figure out what the sign is, and that'll tell us if we're moving up or down with the resultant. That's why I was like, I don't really know. What do you end up getting?
I got a bunch of answers. I got
Bunch.
49.
Definitely, I mean, look at this, James.
It's got to be negative.
Can't be 49. I mean, look at the numbers themselves. These are, and I just said, these are all decimals, sine of angles of decimals. So you did 27 sine 32 minus 35 sine 55.
Yeah, I got like
Are you in hit mode real quick, James? Is it radian or degree
Yeah,
highlighted?
it was a radian. It was
Go to degree.
The first one's wrong too.
Okay.
It should have been like
Just re-enter the first one and second one so I get.
like 42 decimals.
The first one, 42?
I mean, I was like, we didn't fix it.
That's all right. But hey, I'd rather you do it now. Just means that you haven't taken out that calculator in a while.
No, it's just, I had an 83.
I'm messing with you. But you should be using it, obviously, so make sure it's in the right setting. So 42, what was it?
42.97.
Okay. And the y component becomes?
I got minus 14 point, that's all I first.
It should be negative for sure, because this number here turns out that sine 55 is more than sine 32. So this will be a greater weighting factor, so it will be good. So these two values are giving me the lengths of that red triangle right there, which I need to now redraw my ry because it's going down. Because remember, see, the resultant was negative, this resultant was positive. So with the x, it means I move to the right. And since this was negative, it means I should actually move down. So my sketch that I drew in the beginning is not actually correct. So remember, your sketch is, if it's not drawn to scale, you can't really utilize the information from it, right? It's not really reliable in that sense. Okay? So really, my answer should have looked like this, where ry comes down right here. It's not this piece at the top. I'm going to cross that off. I can't erase it right now. Okay? And that'll be the actual triangle we're looking for. And that'll be the resultant that we're looking for right there. So this is Rx right here. This is overall R. Just because this one kind of got covered up. So here's Rx, here's Ry, and that's the overall R value that we're really looking for. So if I were to redraw my original vectors, we would see that the second one was not drawn to scale. The second one should have been drawn from the point all the way down to here. That's where it should have looked like. And that's my angle of 55 degrees. So this is not what the second one should have looked like. I'm crossing it off. See? So now, because I know the answer, I can make it look the right way. But prior to this, I didn't know what the answer was, so unless I drew everything perfectly to scale, you can grab a seat. I'm going to work with you in Sebastian also, yeah. Unless I know the exact angles and lengths of the protractor, I can't estimate what my answer will be, with some reliability or some confidence. So instead, I use the x component and the y being negative to give me what it should look like. So what I'm getting at is that you don't really need the diagram, if you can tell. If you can just do this operation on the table every time, your answer will give you the overall diagram. You don't need to actually do this whole piece. If visualizing it isn't helping you, you might want to just go right to the table approach and just do this for every vector. With one caveat I want to add before I jump to them for a minute, because I'm going to come back and forth after. Let me take the questions first.
Could you use the diagram here?
That's what you have to do to get overall R. So you're going to do, because look, it's a right triangle. So you're going to do Rx squared plus Ry squared equals R squared. You have numbers. Say again?
How do you know it's a right triangle?
Because you're drawing an X component and then a Y component, and X and Y always meet at.
Oh, I meant the first one you drew. Like the 27, 35, like could you use those to, is that
Well,
right?
No, Pythagorean theorem allows you to find the third side. You don't have any sides. It's not even like a triangle, really. Remember, see this number here, 27 cos 32? That's this length. That's before you guys came in right after we talked about this. This length right here is that number. This right here is that height right there. So you're finding these legs with trig ratios like we talked about. You're not finding, right here, these two. You're finding these legs with trig ratios for these pieces. You're not using Pythagorean theorem there. Because Pythagorean theorem is only useful when you're missing one leg, right? Here you have the hypotenuse, but you need the base and you need the height. So theoretically, once you found the base, you could find the height by using Pythagorean theorem if you want to, but it just doesn't make sense. Use the component method and it's much faster. It just takes practice to do it more. Okay, these are on your formula sheet. It's the first formula on your formula sheet, that little triangle there shows it. Jeff?
So basically for these type of problems, we should just draw it out first, and then if we want to use the table, then input the value?
I think you should use the table for sure. I think it's an organizational tool that helps. I think that drawing it might help you visualize. But if the diagram is confusing you, then just go with the table method and practice enough and it becomes second nature. But I think the diagram helps to explain it sometimes, to see it visually. That's why I draw the diagram.
So you could just go straight to the table and input.
Absolutely, every time. And the only thing about the table you have to remember is that if a vector isn't drawn at an angle, what happens if a vector, right? Let's just hypothetically real quick, right? So this problem's over. We have to find the resultant, and we have to find the angle theta. By the way, here's the angle theta, if you want to draw it in. That's the angle theta you're going to be finding in this diagram. Remember, it's the angle between the resultant And then here's the x-axis, which is this original one you started at. So here's the angle theta, and r is the resultant, which you can find using these sides of the triangle. But let's say for a quick moment, you just have to imagine this, that after this person completes the second, whatever, path along their journey, they decide to walk north, let's say like 40, whatever these are, miles or meters, whatever units we've been using the whole time. 40 units north. 40 units north. So instead of stopping at the end point of the black then blue vector, follow the gold vector up to see where the person ends. So where is this person clearly going to end? In what quadrant? Well, it's almost clearly, it looks like, assuming it's drawn to scale kind of. Instead of ending in the fourth quadrant, yeah, in the first quadrant, what are these both? What kind of numbers are these both in the first quadrant? They're both positive, aren't they? So think about what that would do. In the first quadrant, x and y, aren't they both positive? This is like coordinates, ready? This is a coordinate of 4297 over, and then down 14.4. This is right here. That's the coordinate we're looking at. You see how this is the x and the y? You're gonna give me a weird look. That's one.
No, yeah, because like I didn't know you meant like when it goes up top. I thought you meant negative 14.
So this, yeah, this becomes positive when it slides up
Yeah.
here. This is still the same number, right? It's still 42.97, and then up some value. Agreed? So this is not changing, is what I'm saying. Because look at the gold component. It's only drawn in which direction? The vertical, in the y. So you don't have to break this up into 40 cosine angle, 40 times the sine of the angle, because there is no angle. It's just drawn straight up. So you would just tack on 40 right to this number right here. You just add 40. And the way you would show that, I'll drop in like a little vector length here, c, call this vector c. The x component would be 0 and the y component would be 40. That's what vector c would look like. Because it's not drawn left to right at all. It's only drawn up and down. And in this case, it's only drawn up. So you put a positive 40 in this position for vector c's y component, a 0 for the x component. I have 3.5 more videos on Moodle that I've been really encouraging you guys to watch. So I'm going to stop because I have to work with the math students right now. But if you want to try another one of these, try the basketball court one right now while you're waiting. You got like 10 minutes and then I'll come back and we'll go over it. But this means that tonight you need to start looking at these videos if you're really having trouble with this. Because it's not an easy topic, but you have to practice it more. And that's why I put up like 3 more full examples recorded. One with the table method and then 2 others without the table method. So if you don't want to use the table method and it's confusing you, maybe look at those other videos. But if you kind of get this, you want to just see a little bit more using this table idea, definitely take that approach.
I just have a super fast question.
Yeah.
For the problem sets,
Yeah.
if we make a mistake, would you rather see error corrections, or like, so if we realize we did something
Is
wrong,
it in Notability or is it on paper?
if it's on paper, but it's like,
Are you writing in pen or are you writing in pencil?
pen?
Then I have to see a mistake, so why'd you ask?
Okay.
You understand, Joe?
Yeah, I was just
If you're writing in pencil, then I would erase it and fix it.
Yeah,
If I'm writing in Notability,
Yeah, I crossed it out neatly, but I could have, like, I was.
in the future, I would write in pencil when I'm doing something like
Okay.
this, because it's an assignment you want to make sure is right. But it's not the end of the world, Joe.
All right, thank you.
I have a question about the next problem, which is 26, which says use the component of the vector to find the magnitude direction angle.
Is this the basketball one?
No, this is the second part of like 25, it's 26.
Okay.
It's just about 25. Then it's to find the magnitude direction angle of vector c. So I was confused about, is what we like wrote as r, is that just what c was supposed to be?
Yeah, I think in the beginning they defined A plus B equals C, right?
Yeah,
Yeah, so we called it R. It's C, same thing.
okay.
So the magnitude is 45.3 and the direction is 18.5 degrees southeast. This is the magnitude, this is the direction.
Okay.
It probably broke into little pieces for you, right? It said find the components, then it said find this. So it's doing exactly what we did. The components are in red right here. There's Rx and Ry. You're done. That's the first part. And then putting them together is the second part. Okay? Yeah, it's a good question, understanding what the wording of the problem actually means.
I